Hello everyone, let's continue our discussion. In this question, there is a combination of convex lens and a plane mirror. And according to the description that is given in the question, a point object is placed at a distance of 60 cm from the convex lens whose focal length is 30 cm. So definitely the object will be here. The question further says that if the plane mirror were put perpendicular to the principal axis and the distance between plane mirror and the lens is 40 cm as it is described, then we have to find the position of the final image formed by this combination and the nature of the final image as well. So the focal length of this lens is 30 cm. Immediately we realize that twice f will be 60 cm and object initially it is located at 60 cm. So we realize that object is placed at twice f. Let's attempt this question step by step. Let me draw this focus. This is 30 cm point, focal point. This is again 30 cm point, focal point, first principal focus. And this object is located at twice f. Now, what will be the first image formation? We know from the image formation diagram that whenever object is placed at a distance of twice f, then after refraction from the convex lens, the image, a real image would be formed at a distance of twice f only. And this image will be real image. But in this case, this particular mirror is blocking this image formation. Therefore, this particular mirror will basically reflect the light back. Since this image would have formed at 60 cm, distance between lens and the plane mirror is 40 cm, so this distance will be 20 cm. Again, since this mirror is plane mirror, this distance is 20 cm, thereby this distance will be also 20 cm. Now here the real rays of lights are intersecting. We will see one real image. We will see one real image here. But is this the final image? No, this is not the final image, because the rays of light will further go like this and these lights will refract from the lens. So at this point, although we will get one real image, but this real image will now act as the second object for this particular lens. I will do this calculation here. Let me draw it. This is the second object formed by the real rays of light, and this is the point which is the focal point, 30 cm. Now since this distance is 20 cm, this distance will be also 20 cm. So this is 20 cm. What's that? If I consider this ODES to be the object for this particular lens, then 20 cm will be the object distance. Now for this object, what will be the image? We see that the focal length is 30 and object distance is 20. Therefore, from the image formation diagram, we realize the image will be a virtual image. So what will be the position of the virtual image? That we can calculate using lens equation. We will have to apply lens equation. Now, whenever we want to apply lens equation, we know we apply the sign convention also. What sort of sign convention? New Cartesian sign convention. What's that? Whenever we apply new Cartesian sign convention, we should note that object is always placed in the left hand side of the lens or the mirror, and rays of light travels towards the right. And under this convention, we consider the signs according to the Cartesian coordinate system. For example, in this convention, all the distances measured along the positive x-axis, that is right hand side, will be positive, and all the distances along the negative x-axis will be negative. But here in this case, the object is placed along at the right hand side of the lens. Therefore, the normal convention that we use to solve this optical problem will not be applicable. It will be reversed in this case. Therefore, although this distance, this object is on the right hand side, we have to take this distance to be negative because the object is now on the right hand side. So this will be minus 20. What will be the focus? Focus will be 30. What will be the sign of the focal length? Again, it will be this focal length will be positive because now first principal focus will be here. So this is 1 by 30. So V will be equal to 1 by 30 minus 1 by 20. When you take LCM and solve this particular question, you will get that you will get the image distance minus 60. Minus 60 means, in this particular convention, minus means right hand side. So image will be formed at a distance of 60 centimeter from the lens. What sort of image will be this one? Whether it will be real image or the virtual image. Now realize, the object distance is less than the focal distance. Under this case, virtual image is formed because the rays of light cannot converge enough to form the real image. So we extend their direction and the final image is formed here. That's the final image. Now from the mirror, what is the position of the final image? 20 centimeter. So it's a virtual image 20 centimeter. So that's the answer. So 20 centimeter from the plane mirror, it will be a virtual image. Now in this particular problem, we have learned something. We know that plane mirror always forms a virtual image, right? But we realize that if somehow converging rays of light fall on plane mirror, then after reflection, real rays of light will intersect. Then at this intersection, real image will be formed. It is possible. Now, whether this image will be final or it will be not final, it will be decided by whether this rays of light suffers refraction or reflection further or not. In this case, this is not the final image. But if it happens that this rays of light goes on without any reflection or refraction further, then this will be the final image. So yes, it is also possible to form real image with the help of plane mirror under this condition. Let's move on. Here in this question, 3 resistors are given and corresponding currents are given. This question belongs to current electricity chapter. And according to the description, this I1 passes through R1, I2 passes through R2, I3 passes through R3. And we are supposed to find this refraction ratio, I3 divided by I1. When I see this question, I realize that this I1 gets splitted into 2 parts. I1 splitted into 2 parts. Whenever current splitted into 2 parts or 3 parts, I realize that Kirchhoff's current law is working here. So I have to apply Kirchhoff's current law. Secondly, this R2 and R3, they are parallel to each other. Again, whenever 2 electric components are parallel to each other, then the electric potential drop across them will be equal. So I will start from this point. Electric potential drop on R2 equal to electric potential drop on R3. According to Ohm's law, electric potential drop will be current multiplied by this one, and for R3 this one, which means I2 divided by I3 will be equal to R2 by R3. At this moment, I keep this relation as it is and I work with the Kirchhoff's current law. According to Kirchhoff's current law, I can see this I1 splitted into 2 parts, I2 and I3. Let me write this relation, I2 plus I3. Now, let me divide this relation by I3. So I2 by I3 plus 1. Since I already know the value of I2 by I3, which I have calculated here, I will put this relation here. This will be R2 divided by R3 plus 1. Let me calculate further. So this will be equal to, I think this is R3 and this is R2. R3, R2. Anyway, R2, R3 plus R2. And the answer comes out to be R2, R3 plus R2. So option B is option 2 is the correct answer. Let's move on. This question belongs to the digital electronics. Whenever a question which is based on the digital electronics appears in front of you, you should note 2 points. That in digital electronics, one logic circuit will be given. So how you will approach the problem? So two things you have to remember. First, the final logic operation of the output. Second thing is the truth table of this circuit. If you know these two things, you can solve any circuit, any problem based on the digital electronics. So let's attempt this question. Let me write down I will try to write the truth table for this particular circuit, A, B, C and Y. Here the inputs are given in form of pulses. It is not given in terms of 1, 2, 1 or 0. So I will consider, or we should in fact consider this 5 to be 1 high value and 0 to be the low value. For the first instant, for the first pulse, A is 0, B is 0 and C is 1. Let me apply this one. 0, 0, 0, 1. This gate is AND gate, so 0 into 0 is 0. This is NAND gate, 0 into 1 is 0, but complementary will be 1. This gate is OR gate, 1 plus 0 will be equal to 1, so output will be 1. 1 means 5. Let me go to the next pulse. In the next pulse, A is 5, that means it is 1. B is 0, 0 and C is 1, 1. Let us apply this set of values. A1, B0 and C1. So 1 multiplied by 0 will be again 0. 1 multiplied by 0 will be 0, but the complementary will be 1 in this case. This OR gate will make the output 1, 0 plus 1, again 1. Two consecutive pulses are giving high output. So only 3 is the option where first two consecutive pulses are giving high output. So option 3 is the correct one. Let's move on. This question belongs to the LCR circuit. LCR circuit means it involves inductor, it involves capacitor and resistor. And according to the description that is given in the question, this LCR circuit is connected to one AC variable voltage source with a certain frequency, with variable frequency of course. Now when you change the frequency, of course current will change as well as the power will change, that we know for LCR circuit. Now we are supposed to find the angular frequencies of the source at which the power transferred to the circuit is half the power at the resonance frequency. First of all, at resonance frequency the power becomes equal to maximum. Okay, how the power changes with the frequency? Well, let's say this is the power. We see that the power first increases and then it decreases. At a certain frequency the power becomes maximum. This frequency is called the resonance frequency. And then at two frequencies, one is called lower cutoff frequency, one is called upper cutoff frequency, the power becomes equal to half of the maximum power. Or these two frequencies are the frequencies at which the current in the circuit becomes equal to 1 by square root times the current. Now this difference is also called the bandwidth. Okay, and then what is the value of the lower cutoff frequency? This is calculated to be resonance frequency minus R by twice L, and then the upper cutoff frequency is resonance frequency plus R by 2L. Well, to solve this problem, to get the value of omega 1 and omega 2, which are our answer, we need to find omega naught. What is omega naught? Resonance frequency. What's the formula? Square root of LC. Secondly, we also have to calculate R by 2L. We need the value of this one and we need the value of this one. Then only we can solve this problem. Let's calculate one by one. First, consider the resonance frequency. What's the value of L? L is 5 Henry. So let me put 5. What is C? C is 80 microfarad. So this is 80 multiplied by 10 power minus 6. Let me solve it. This will be equal to 400 multiplied by 10 power minus 6 square root. So 20 multiplied by 10 power minus 3. So this will be 0.05 into 10 power 3, which is equal to 50 Hertz. So that's the frequency, resonance frequency. Now let's calculate this term. What is R? According to the question, the R is 40, L is 5. Thereby this term will give us 4 Hertz. So lower cutoff frequency will be equal to 50 minus 4, which is equal to 46, and the upper cutoff frequency will be 50 plus 4, which is equal to 54. So answer is option 3. Let's move on. This question is telling us that there is a car. It is starting from the rest and then it starts to accelerate at a rate of 5 meter per second square. And then when this car was moving, at an instant when time was 4 seconds, a ball was dropped from the car. Okay, dropped from the car. And then we have to find the velocity of this ball and the acceleration of this ball at time t equal to 6 seconds. Okay, now let us proceed. So the situation is like this. This is the car. It was moving and then it will acquire some velocity. When this particular car will acquire some velocity, the ball inside the car will also acquire some velocity. Now at the moment when the ball was released, that time the speed of the ball or the velocity of the ball will be equal to the velocity of the car. Therefore both the speeds will be horizontal speed. Now as soon as this particular object was dropped means there was no velocity, extra velocity given. So vertical velocity, initial vertical velocity will be 0. This ball will follow one horizontal projectile trajectory. So this ball was projected like this with horizontal velocity, it will strike it like this. So it's a horizontal projectile. And in horizontal projectile we know the horizontal acceleration becomes 0. It is in fact 0, and the vertical acceleration is acceleration due to gravity, which is 10 meter per second square. So 10 meter per second square is mentioned only in the option number 4, which is the answer. Again, this particular ball will not feel this acceleration after the drop because it is already detached. Let's move on. So here in this question, there is a particle of mass m. It is projected with a velocity v equal to k v suffix e from the surface of Earth. And it is mentioned in the question that this ve is the escape velocity. This escape velocity is the escape velocity from the surface of Earth, although it is not mentioned explicitly. And we are supposed to calculate the height above the surface reached by the maximum height above the surface reached by the particle. This r that is mentioned in the option is nothing but the radius of the Earth. Okay, radius of Earth. So context is the following. This is the object. Let's say mass of the object is m. This object was projected with a certain velocity. It will reach a certain point, which is the maximum height. Maximum height means what? It cannot go further. It cannot go further means what? Its velocity at this particular point was 0. Let's say that point is B and this initial point is A. Let's say h is the height up to which this particle or the object was able to reach. The radius of the Earth is r, from the center to this point the distance will be h plus r. Now how we will solve this question? We will simply write down conservation of mechanical energy. We know that gravitational force is conservative force, and whenever conservative force is in question, then we can always apply the conservation of total mechanical energy. So total mechanical energy at A must be equal to total mechanical energy at B. What is total mechanical energy at A? At A, first energy will be the kinetic energy, half of mv square. Second energy will be the gravitational potential energy. What will be that? It will be G capital M small m divided by distance between this mass and the center, which is R. This should be equal to the total energy here. What is total energy at the highest point? Since the velocity is 0, kinetic energy will be 0. So potential energy will be the only energy. So Gmm divided by the distance between this point and this point, which is R plus H. Now, this velocity, the projection velocity that is mentioned here, according to question, it is equal to K multiplied by VE. And this VE is nothing but the escape velocity of Earth. So escape velocity is 2 capital Gm divided by R. At this moment, I assume that you can remember this. So if I square it, it will be equal to twice of Gm divided by R. Now what I will do, I will put this value here. So half into m multiplied by k square Gm divided by R minus Gmm divided by R equal to minus Gmm R plus H. So this Gmm will be cancelled. This 1 2 will be there. This 2 will be cancelled with this 2, and then we are left with k square by R minus 1 by R equal to minus 1 by R plus H. Now we will solve this to get the answer. R k square minus 1 is equal to minus 1 R plus H. So this will be equal to 1 minus k square divided by R equal to 1 by R plus H. I have just multiplied with minus sign both sides. Then let me take the cross product. So this will be equal to R by 1 minus k square equal to R plus H. Thereby the H will be equal to R 1 minus k square minus R. I will calculate here. So this will be equal to H 1 minus k square R minus R plus k square multiplied by R. So this R will be cancelled. So answer will be option number 4. Let's move on. Okay, so this question is based on the combination of two concepts. So the first para of the question describes a circular motion, second para describes a projectile motion, and the question is based on the projectile motion. Let's read out the question. So according to the question, a particle is moving in a circle of radius r in a uniform speed, and it takes t time to complete one revolution. That means this time is time period. And since it is moving with uniform speed, then this circular motion is uniformly circular motion. So I will simply write it like this, that object was moving with a, let's say, certain radius r with a certain speed. Let's say the speed is equal to v and the time period is equal to t. And then the second para says that if this same particle were projected with the same speed as it was rotating in the circular motion at an angle theta with the horizontal, then the maximum height attained by it is 4 times the r. Question is, what is the projection angle? The situation, if I want to describe, it will be like this. The same particle, I project it with the same speed as that of the circular motion and at an angle of theta, projection angle theta with the horizontal, and then it goes under one inclined motion. And under this case, according to the question, the maximum height that the particle can reach, it is 4 times r. Therefore, what is the value of theta? First of all, when we want to attempt this question, what we are supposed to find? We are supposed to find theta, right? Then what is given? Height is given, right? Therefore, I will simply write down the formula for the height, which is equal to u square multiplied by sine square theta divided by 2g. Then what is height? Height is equal to 4 times r. this is 2g, then u square sine square theta. What is time period? Time period is equal to 2 pi r divided by u, distance by speed. Thereby the speed will be equal to 2 pi r divided by t. Since I need u square here, I will square this. U square will be equal to 4 pi square r square divided by t square. Now this value of u square, I will put it here in this equation. So this will be equal to 4r. Let me take this 2g here. In place of u square, I will write down 4 pi square r square divided by t square, then sine square theta. 4 will be cancelled with this, r will be cancelled with this one. So 2g multiplied by t square will be equal to pi square r multiplied by sine of square theta. Let us simplify further. 2g t square divided by pi square r is equal to sine square theta. Therefore sine of theta will be equal to square root of this quantity, which is 2g t square pi square r square root of half. So option number 4 is the correct answer. One more thing, since we are supposed to calculate the angle of projection using height, so we should know if this is the angle of projection with horizontal, then formula for the height contains the sine term, not the cos term, vertical velocity term. So anyway, option 1 and option 2 could not be our answer. Okay, so let us proceed. This question, it looks like that this question belongs to the magnetism, but without knowing the magnetism concept, we can solve this. So according to the question, F is equal to Q in bracket V cross B. And then the velocity is given this one, F is given this one, and we are supposed to calculate the magnetic field B. First of all, the question is not describing whether F is force, V is velocity, B is magnetic field. It is not required as well. We are supposed to calculate the expression for B. How we will do this? We know in case of vector product, let's say I take vector product, let's say any two vector A cross B. When I take A cross B, this A cross B itself is a vector. Let's say that vector is C. When we concern about the direction of A cross B, we know that A cross B is perpendicular to A and B separately. So this C is perpendicular to A, and we know that whenever two vectors perpendicular to each other, then their dot product or the scalar product becomes equal to 0. So in this case, C dot A will be 0 as well as C dot B will be also 0. Now come to the problem. This is the relation given. F is equal to Q is given to be 1. Even if it was not 1, it was not a problem because it's a scalar quantity. So F is equal to V cross B. Thereby I understand that this F dot B should be equal to 0 always for any value. Therefore which value of B will be correct? The value of B will be correct which satisfy this particular formula. So one by one I will check all the option. So I will just check the option number 2 because I already know that option number 2 is the correct one. So F dot B, what is F? F is equal to 4i minus 20j plus 12k. This is minus 6i cap minus 6j cap minus 8k cap. So this will be equal to minus 24 plus 120 minus 1 minus 90. 12 into 8 is 96. So this will be equal to 0. So that's the answer. So it is giving 0. You will realize that when you check the same for option number 1, 3 and 4, you won't get 0. Let's proceed. So here in this question, a ball whose mass is 0.15 kg is dropped from a height of 10 meter. It strikes the ground and rebounds to the same height, and we are supposed to calculate the magnitude of impulse imparted to the ball. Magnitude of impulse means change of momentum. Change of momentum. This ball was initially, let's say, at this position. So height was equal to 10 meter, and it was dropped means the initial velocity was 0 at this point. When it strikes the ground, it will strike the ground with a certain velocity, and we know that velocity from the motion chapter. We know, and we can easily calculate that it is square root of 2gh. How? We can apply the equation of motion, that final velocity equal to initial velocity plus 2g multiplied by distance, which is equal to h. Now, since this particular ball again rebounds to the same height, it means there was no loss of energy. It is called elastic collision. Therefore, in this kind of situation, this striking velocity and the rebound velocity will be same in magnitude. Direction will be different. Now, what is the change of momentum? The change of momentum will be equal to the final momentum minus initial momentum. What is final momentum? Final momentum is mass multiplied by velocity, if I take upward direction to be positive, minus the initial momentum. Initial momentum is, let us consider the velocity, since it is downward, minus. If I consider upward velocity to be plus, downward I have to consider minus. So change in momentum will be equal to 2 times mv. So 2 multiplied by m multiplied by this v is nothing but 2gh. Now let's put the value. M is 0.15 multiplied by 2 multiplied by 10 acceleration due to gravity multiplied by this. This is 0.3 multiplied by 10 multiplied by square root of 2. This will be equal to 3 multiplied by 1.41. So the answer will be equal to approximately 4.2. That's the answer. Let's move on. This question belongs to the magnetism chapter. According to the description that is given in this question, there was a wire whose length was equal to 12 times A, where A is a constant. It's a unit. There are 12 units I can consider. And the resistance of this wire was equal to R. And this particular wire can also carry some current. And it is given that when this wire is transformed into a equilateral triangle whose side is A, then it will give one magnetic dipole moment. Again, the same wire, when I transform it into square, then also it will give magnetic dipole moment. So what will be the magnetic dipole moment in each cases? So that I have to identify. First of all, what is magnetic dipole moment? This magnetic dipole moment is equal to amount of current multiplied by area. If the number of loop is, let's say, n, then I have to put n here. Now let me form one triangle using this wire. So if I want to form triangle, equilateral triangle, so it will be like this: side A, side A, side A. So how much length will be required? 3A length will be required, but we have 12A. So how many rounds will be possible? How many triangles will be possible? The number of triangles will be 4. Therefore, the number of this will be 4. So what will be the magnetic moment? The magnetic moment is equal to n multiplied by amount of current multiplied by area. So n is 4 multiplied by current. What is area? The area of equilateral triangle is square root of 3 by 4a square, the side square. So this will be equal to square root of 3ia square. So for the triangle, this is the magnetic moment. Only this term which contains this answer. So the option 1 is the correct answer. Again, you can perform the same for the square as well to calculate. Let's proceed. According to the question, there are 27 drops. Okay, 27 drops. I assume that they are non-conducting, and all of them are same size. Same size means their radius are same and volume also same. Now what happens is that this 27 drops transform into bigger drop. Let's say the bigger drop is having radius r. Initially, each drop was charged at a potential 220 volt. Let's say the charge on the surface or charge on each drop was equal to q. Since it is non-conducting, so charge will be distributed uniformly. So how many drops are there? 27. So we know that the total charge will remain constant. So after transformation also total charge will be 27q. We are supposed to calculate the amount of potential on the bigger drop. Okay, what is this? Now we know that the potential on the surface will be amount of charge 4 pi epsilon naught divided by the radius. In this case, what is the amount of potential? The amount of potential is equal to, on each drop it will be equal to amount of charge on each drop 4 pi epsilon naught radius. I consider the radius to be r. Now in order to solve further, we need to know the relationship between their radius. So first of all, when this particular drops transform into bigger one, the volume will remain constant. The volume of each small drop will be equal to 4 by 3 pi r cube. How many drops are there? 27. This volume should be equal to the total volume after formation of the bigger drop, which is 4 by 3 pi capital R cube. Thereby what I get is that 27 r cube to be r cube. So this r becomes equal to 3 times r. Now what I will do is that using this one, I will calculate the value of V. So let me divide this V divided by V1. This V1 is, remember, it is 220 voltage of each drop. So this will be equal to Q by 4 pi epsilon naught R, 4 pi epsilon naught small r by small q. So this is 27q. This portion will be cancelled. This is 3 times r multiplied by q, and this is r. V divided by 220. So this will be equal to q cancel. So V will be equal to 9 multiplied by 220. So this is equal to 1980. So option 4 is the correct answer. Let's move on.